Alright, get ready to dive into something seriously mind-blowing today, gravitational waves. You guys sent us some incredible questions on this topic.
Yeah,
We're talking about ripples in spacetime itself. Imagine the universe actually shaping, whoa. Okay, so like those old sci-fi movies where spaceships warp space? That's actually real?
yeah,
Exactly. It's wild that we can even detect these waves. Picture this, a bowling ball on a trampoline. Okay, I'm with you. That's your planet, a star, anything massive, warping spacetime. Now, picture two of them spiraling toward each other super fast. The trampoline doesn't just warp, it ripples. Those are gravitational waves. I can picture that. So, Einstein predicted these waves way back in 1915, but why did it take so long to actually find them? Well, detecting them is like trying to hear someone whispering across the entire universe. It took a century of science just to develop instruments sensitive enough to even pick these faint signals up. Wow. So, what kind of technology can actually pick up a cosmic whisper? That's where LIGO comes in, the Laser Interferometer Gravitational Wave Observatory. LIGO, right? Every time I hear that, I think of something straight out of Star Trek. Huh.
yeah,
It does sound pretty futuristic, but get this, imagine lasers shooting back and forth between mirrors that are miles apart. Miles apart?
yeah,
By measuring how long it takes the light to travel, they can detect changes in distance smaller than an atom. That's the sign of a passing gravitational wave. Hold on, so these waves are coming from massive cosmic events because changes smaller than an atom? That's insane.
yeah,
It's a testament to how powerful these events are and how sensitive LIGO is. Like that first detection back in 2015, GW150914. Two black holes colliding, right? I remember reading about that. That was huge. Huge doesn't even cut it. Two black holes, each 30 times the mass of our sun, smashing together for a fraction of a second. That collision released more energy than all the stars we can see combined. And LIGO caught it. Whoa. I bet there were some skeptical scientists before that, right? It almost sounds too incredible. Absolutely. For a long time, people thought detecting these waves was impossible, even with Einstein's theory. But there was a key piece of evidence before LIGO, the discovery of a binary pulsar. A binary what? You lost me. Okay, so think of a pulsar like a rapidly spinning lighthouse, emitting beams of radiation. Now, imagine two of these lighthouses locked in orbit around each other, that's a binary pulsar. Okay, I'm picturing it. Go on. Scientists Hulse and Taylor observed that the orbit of this binary pulsar was actually shrinking, just a tiny bit over time. The rate of shrinkage matched perfectly with what Einstein predicted for energy loss through gravitational waves. So, like finding the smoking gun but not the actual crime scene? Exactly. It gave everyone confidence that LIGO was on the right track. But nothing could prepare them for that first detection, it shook the world of astrophysics. Literally. So, discovering these waves is incredible and all, but it makes you wonder, why does it even matter? What can we actually learn from these cosmic ripples? Great question. It's like we've suddenly gained a new sense, a whole new way to experience the universe that was hidden from us before. So, instead of just relying on sight, now we also have hearing? Exactly. Up until now, we've mostly relied on light to study space, radio waves, X-rays, and all that. But gravitational waves give us a totally new perspective, it's like we can feel the vibrations of the universe itself. I like that. So, what secrets has our new sense revealed so far? What's got you most excited? For one thing, we're learning a ton about black holes. They're even more mysterious than we thought. Oh, way more. I mean, before, we could only study them indirectly, seeing how their gravity messed with nearby stars and gas. But now, we're witnessing black hole collisions directly. And what we're finding is mind-blowing, black holes with crazy masses and spins, stuff our old models couldn't explain. It's like discovering a new species of animal that throws all the biology textbooks out the window. Exactly. And it's not just black holes, we're also learning a lot about neutron stars. Neutron stars. What are we learning about those? Oh, neutron stars are where it's at. Remember those binary pulsars we talked about?
Yeah.
When two neutron stars collide, it's not just ripples in spacetime, it's insane explosions. Some of the most powerful in the universe. Intense. It's not just the power, though, it's what they create. These collisions are so powerful they actually forge heavy elements. Wait, what? Like what? Like gold and platinum. They get created in these massive cosmic collisions. Hold on, so the gold necklace someone might be wearing was forged billions of years ago in a neutron star collision. Exactly. Pretty amazing, right? That's mind-blowing. It really connects us to these events in a way I never thought of. Okay, so if gravitational waves can tell us about events billions of years in the past, could they tell us about the Big Bang itself? The Big Bang. Now you're going way back. Can we really catch echoes of that with these waves? We haven't detected waves directly from the Big Bang yet, but the potential is there. Imagine a message from the very beginning of everything, carried on these ripples, that'd be incredible. Even without going all the way back to the Big Bang, we've learned so much already. What does the future hold for all this? This is just the beginning. And we're not just listening for more black holes and neutron stars, though that'll be amazing on its own. Scientists are building the next generation of detectors, the Einstein telescope, cosmic explorer, way more powerful than LIGO. Way more sensitive? Think upgrading from a basic telescope to the James Webb, but for gravitational waves. We'll see fainter signals, further back in time, and make new discoveries we can't even imagine yet. That's insane. And it gets even cooler, we're not just limited to Earth anymore. There are plans for space-based observatories like LISA, the Laser Interferometer Space Antenna. Gravitational wave astronomy in space. Okay, tell me more. LISA will pick up a whole different range of waves, including ones from supermassive black hole mergers, the huge ones at the centers of galaxies. So we're talking galactic-scale events here? Exactly. This is amazing. But what about the theory side of things? You mentioned some really mind-bending stuff earlier, like a particle that could help us understand how matter was even created? You mean gravitons. Now we're getting into some pretty wild theoretical territory. Imagine pure energy, like light itself, compressed so tightly by gravity that it becomes this dense, stable knot. That's the basic idea. A particle born from pure energy and gravity? Wild, right? Some physicists think gravitons, if they're real, could be the key to how matter was made in the early universe. This whole deep dive has been incredible, from mind-bending physics to the very edge of what we know about the universe. And we're just getting started. We've opened a whole new window into the cosmos, and it's already changing how we understand everything out there. Who knows what we'll find next? For everyone listening, if you're as blown away by all this as we are, check out the source material. Maybe you will make the next big discovery.